Assalamualaikum warahmatullahi wabarakatuh. Today we will be presenting on the mini project for MEC523 Applied Electronics and Microprocessor. Our group project is on a smoke and fire detector. Before that, I would like to introduce myself. My name is Ariff bin Awang Abdul Rahman and my teammates are Tengku, Imran, Amirul, Asyraaf bin Tuan, Zamri, Erazam and Nik Muhammad Haikal bin Nik Muhammad Hisyam.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Imran Amirul Asyraaf bin Tuan Zamri Erazam from class EMD6M1A1. Today, I will be presenting about my part which includes background, motivation, and objective. A smoke detector is an electronic fire protection device that automatically senses the presence of smoke as a key indication of fire and sounds a warning to building occupants. The first automatic electric fire alarm was patented in 1890 by Francis Robbins Upton, an associate of Thomas Edison. Then, in the late 1930s, Walter Jaeger has built a sensor and done an experiment, and it became one of the advances that paved the way for the modern smoke detector. Later in 1955, simple home fire detectors were developed, which detecting high temperature, followed by invention of the first low-cost smoke detector for domestic use by Tuan D. Purcell with Stanley Bennett Peterson in 1965, which has an individual repressible battery-powered unit that could be easily installed. Smoke detectors in large commercial and industrial buildings are usually connected to a central fire alarm system. Domestic smoke detectors range from individual battery-powered units to several interlinked units with battery backup with interlinked units. If any of them detect smoke, all of the alarms will trigger even if household power has gone out. Research shows that the risk of dying in a home fire is cut in half in homes with working smoke alarm. For our project, we designed a fire and smoke detector system by using Arduino Uno in Tinkercad software. To be specific, we aim to create a fire smoke system using Tinkercad which has two inputs, that is usage of gas and temperature sensor TMP36. The gas and temperature sensor will produce three outputs, which LED light is turned on, alarm piezo will make loud noise, and lastly, LCD screen will display the warning sign. Our motive is to help in reducing the incident which causes people to lose their belongings, properties, spirit, and life if fire outbreak happens. To help in that matter, a system for fire and smoke detector that alert people if there is fire outbreak in their properties should be designed and implemented. We choose to create a fire and smoke detector system which is completely functioning to be used in modern community to reduce the death case. For our project, we use Tinkercad because the software is free and easy to use. Objectives of our project are to study the working principle of fire and smoke detector system, then to design and construct the fire and smoke detector system by using Arduino Uno in Tinkercad software, which has two input and three output, and lastly, to be able to show the circuit, flowchart, and implemented the coding for the software to run and display the simulation of the project.
My name is Muhammad Haikal. I'm going to talk about the product. First is programming flowchart. This is our flowchart. First we declare the temperature and the smoke integrity as variable, and then the program will read the temperature and the smoke meter, and then there's a for condition which is temperature, above 80 degrees or less than 80 degrees, and then the smoke integrity is more than 100 or less than 100. All the result will be looped back into the program to read the new temperature and the smoke meter. Next, I'm going to talk about circuit diagram. This is our circuit diagram, and this is our list of components that we use in this project. Now, the first one is Arduino Uno 3, and then small breadboard, and then one LED, and then one buzzer, and then we use 4 unit 1 kilo ohm resistor, and then we use temperature sensor to detect fire, and then gas sensor to detect smoke. Lastly is LCD to display text such as warning such as fire and smoke detected. Next, I'm going to talk about the coding. This is our coding. Firstly, we set the variable, and then we set the variable into output or input, and then we set the condition. The first condition is if the temperature equal to or more than 80 degree and the gas sensor is more than 100. The next condition is temperature more than 80 degree but the gas sensor is less than 100. The next condition is temperature is less than 80 degrees and the gas sensor is more than 100. And final condition is the temperature is less than 80 degrees and the gas sensor is less than 100. Next is the coding for the serial monitor. This is for the temperature degree, the temperature sensor, and the below one is for the gas sensor. Both is used to read the value for the temperature and the gas concentration. Next is I'm going to talk about the results. This is how our product function. First, we set the temperature into more than 180 degrees, and all the output is activated. There's the serial monitor that tells the value of the temperature and the gas sensor. And then we put the smoke to activate the gas sensor, and then the LCD will print fire and smoke detected. After that, we turn off the temperature sensor, and the LCD will print smoke detected. After that, we remove the smoke, and then the LCD will print normal condition and save.
Next, I will be presenting on the discussion for this mini project. This mini project aims to develop a system that have the capability to detect temperatures and gases that are hazardous to humans. These two functions can operate independently from one another. This feature is important as people tend to think when there is fire, there is smoke. On the contrary, there are possibilities of which there are fires with no presence of smoke. These fires could be from high energy density fuels such as alcohol. Alcohol are quite common in households around the world as it is a pastime drink used for consumption. The burning of alcohol produces little to no smoke, hence the use of temperature sensor for detecting the high heat output from the burning alcohol. Meanwhile, the use of gas sensor as a smoke detector is for the use case of small fires that produces less heat but have a higher smoke output. Fire, such as burning from newspapers or even food burning on the stove, produces a large amount of smoke that can be detected by the system. Using Tinkercad as a medium for running the simulation for the system, the result shows that the system works as intended. The system was able to independently detect and trigger when there are either heat, smoke, or both. One of the drawbacks of the system that have been noticed in hindsight is the system would revert once there are no presence of heat or smoke. An improvement of the system would be to have a switch to reset the alarm. The switch must be manually triggered by a person to ensure the safety of the premises. The switch can be added into the current design with a little adjustment to the hardware and coding side of the system. In conclusion, this project has improved our knowledge in microcontrollers and the coding required to fully utilize the controller. The project was able to be completed following the requirements of at least 2 inputs and 2 outputs. The system was able to run as planned as in the flowchart, and the next step in moving forward for this system would be to solve the shortcomings of this project. And with that, I would like to thank you for your time for our presentation.